Hello everyone, welcome back to my channel. I am Pratibha Essa from third semester Electronics and Communication Department at Sri Venkateshwara College of Engineering, Bangalore, affiliated by VTU. In today's session, I am going to discuss about superposition theorem, which is related to network analysis. Superposition theorem in network analysis. Firstly, let us see the introduction to superposition theorem. Superposition theorem, it is a powerful tool which is used in network analysis. It allows us to analyze the complex circuits by breaking them down into the simpler parts. Nothing but as it is used to analyze the complex circuits or the complicated circuits, and it can be break them into and simpler ones are the easiest parts. Superposition theorem is based on the principle that the responses of a linear circuit to the multiple sources can be determined by considering each source individually. Nothing but as the responses of a linear circuit which is given to the multiple sources. It can be determined by considering the each source singly or by considering them individually. Now, let us see the statement of superposition theorem. The statement of superposition theorem is it states that in a linear circuit which contains multiple sources, the responses like current response or the voltage response at any point in the circuit which is equal to the algebraic sum of the responses produced by each individual source which is acting alone while all the other sources are turned off. Means that it states that when we consider a linear circuit, it contains multiple sources and the responses at the any point in a circuit which is equal to the algebraic sum of the responses produced by each individual source acting alone or which is acting singly, while all the other sources should be turned off. When applying the superposition theorem, we consider one source at a time and the remaining sources to zero. We have to consider only one source at single time and the rest of the other sources will be considered as zero. Here the proof of the superposition theorem in network analysis. Now let us see what are all the steps included in applying the superposition theorem. Let us see step 1. Turn off all the independent sources except the one we are analyzing. It is means that we have to turn off all the independent sources except that the one source which we were analyzing. For all the voltage sources, we have to replace them with the short circuit such as 0 volts. And for the current sources, we have to replace them with the open circuit. Means there is no current flow or the current flow should be absent in the respective circuit. In step 2, we have to analyze the circuit with only one active source and the rest of the other sources will be 0. Use traditional circuit analysis techniques to determine the responses. The responses such as current response or the voltage response at the desired point in the respective circuit. Here the circuit which is used to apply the step 2. Consider the effect of the active source on all the passive circuit elements. Step 3. In step 3, we have to repeat the previous steps such as step 1 and step 2 for each independent sources. Now we have to calculate the individual responses for each source acting alone and keep track of the directions and polarities of the responses. In step 4, we have to find the total response at the desired point. Algebraically, sum the individual responses obtained in step 3, such as step 1, step 2, and step 3 by considering their directions and polarities. The total response is the final result for the circuit. The total response which is came from the 4 steps is a final result for the superposition theorem circuit. Now, let us see the limitations of superposition theorem. Nothing but as what are all the drawbacks of superposition theorem? Firstly, the superposition theorem is applicable only to the linear circuits. Means that the superposition theorem will only work for the linear circuits, whereas in nonlinear elements such as the nonlinear elements like diodes and transistors etc. can't be analyzed using the superposition theorem. Means that the diodes are the transistors which cannot be designed or analyzed using the superposition theorem, and it is only applicable for linear circuits. The superposition theorem assumes that the circuit is in a steady state condition. It only assumes the circuits which are in the steady state conditions. It is the main limitation of the superposition theorem. Now, let us see the benefits of superposition theorem. Nothing but as what are all the advantages of superposition theorem? The superposition theorem simplifies complex circuit analysis. It simplifies means it makes the easiest which the complex circuit analysis. It makes the complex circuit analysis into the easier form. And the superposition theorem allows us to determine the contribution of each source individually. Means that the superposition theorem, it allows us to determine the what are all the contributions of the each sources individually, and making troubleshooting and fault finding easier. It makes the troubleshooting and the fault finding easiest way. The superposition theorem is widely used in practical applications like electronic circuit design. It is almost used in electronic circuit designs. It is one of the main benefit of the superposition theorem. Now, let us see one example problem which is based on the application of superposition theorem. Let us consider a circuit with multiple voltage sources and the resistors as shown in the circuit. By applying the superposition theorem, we can calculate the current flowing through the specific resistor by considering each voltage source and summing up the contributions. While considering the voltage source, we have considered only the single voltage or the individual voltage, and the respective other sources will be set to 0. This example problem will help us to illustrate step-by-step application of the superposition theorem. Thank you.